JSP INX Prelude, episode number 8. In this episode, we're going to dive into the damaged strut tower that was poorly repaired previously. We're going to figure out what it's going to take to repair it. We're going to do that. We're also going to prepare the engine bay to get painted, and then by the end of the episode, we're going to completely respray the engine bay ourselves. Follow along. The first step to repairing anything that has been previously repaired is just undoing everything that you can that was done by the previous person that repaired it. In this case, it looks like the crack on the strut tower was MIG welded and then covered in a bunch of silicone or sealant. So the first thing we had to do was remove all of that. With the weld exposed, now we can go in and start grinding away so that we can expose the original damaged part of the strut tower. That's the first step to getting into fixing it. I'm going to start with just a 60 grit flap wheel and lightly grind off the top of the weld until I get closer to the original sheet metal. As I get closer, I'm going to get a little bit more delicate and careful with what I'm doing as to not grind into the metal that's around the weld and just grind the weld itself. With most of the weld ground down, we can see the path that the crack was taking along the front of the strut tower, and then from the corner of this triangular bolt pattern down along the face and over to the upper control arm bolt hole mount. After grinding away more of the material, it also became obvious that the mounting bolt hole was actually raised up higher than it was supposed to be. Assuming that the upper control arm bottomed out in the strut tower, it looks like it's lifted this location, which is most likely what caused the crack to happen. Now that I'm beginning to understand sort of what's going on with this strut tower, I'm going to finish grinding off the rest of this weld so that I can get a better assessment of what path we're going to take to do this repair. The next step was to look under the strut tower to see if any of the damage was also done to the underside. At my first glance, I didn't see much damage when I first bought the car because they hadn't done any repair here, so I was assuming that if there was damage, they would have also repaired it down here. But as you would suspect, it looks like the seam here has actually become separated, and the strut tower is actually moved up about 1/4 of an inch to 3/8 of an inch. This is going to need me to grind off all of this undercoating so that we can figure out exactly what else is damaged underneath. I also reinstalled the upper control arm with the nut on top of it so that I could hammer down the locating hole. The nut was screwed on just so that the top of the nut was even with the top of the threads, so that the top of the threads was not mushroomed when hammering. Next, we're going to trace out our cut lines that are going to go around our welded area. You can see the weld is here, and we're going to cut a shape that's around the outside that's easy to duplicate in a template. It's important to be strategic when you're drawing these lines because you don't want to cut out a shape that is difficult to make or also very obvious when it's all completed. Once you're happy with your marked shape, then it's time to cut it out. Be very careful while you're cutting because the more damage you do to the strut tower while you're cutting, the more repair work you're going to have to do. Taking your time here is going to save you a lot of time in the end. After you've removed the sheet metal pieces, you can look inside the strut tower to see the extra damage. And I was able to look also on the back sides of the sheet metal repairs that were done. And as you can see, there's a lot to be desired. The damage to the front of the strut tower was pretty bad, but it did not compare at all to the damage to the back of the strut tower. As you can see from removing the piece of sheet metal that we cut out on the back side, this had extensive damage, and the repair work, they had actually ground down the metal so thin that it was cracking around the weld as they were welding it. This explains the excessive welding, the weld on top of a weld on top of a weld on top of a weld. With all the damage exposed on the top side, let's go back to the bottom and see what else we can find. Looking closer at the bottom, you can see the bottom here where the upper control arm mounts is also cracked. It looks like the people that did the repair previously didn't care to take a look this deep. And not only is the mounting for the control arm cracked, but the whole strut tower itself is actually split. You can also see the areas that lifted up where the seam is separated. We're going to have to grind away all of this undercoating to really expose everything and see what's going on. I just use a wire wheel to scrape all of it off. With the undercoat removed off of the first area that we're taking a look at, we can now see the crack in the strut tower. We can also see that all of the spot welds that were holding the sheet metal together have broken, and the strut tower itself is lifted, like I said, about 1/4 inch to 3/8 of an inch. But I had a feeling that this wasn't all of the damage, so I decided to grind off even more of the undercoating to expose every part of the strut tower. What I found was the whole underside of that right bolt is cracked almost entirely around the hole. I also then exposed that on the left bolt that holds the upper control arm, this was also cracked as well, pretty significantly. In order to repair all of this, unfortunately I don't have a frame machine that can pull the strut tower, so my only real option is to hammer down the strut tower from the top. I continued with a mallet around the circular area of the strut tower until I was able to press the strut tower back down until the spot welds all lined up again. Once the strut tower is in place, then I was able to get in there and start working on figuring out how I was going to weld it up. The first step was to remove the subframe and all of the suspension components out of the way so that I had easier access to weld. After all of the surfaces were realigned and prepped for welding, then I went ahead and drilled little 1/8-inch holes at the end of each crack. Drilling out the ends of each crack is very important to reduce the chance of the cracks spreading after you weld it back together again. Here's a look at the strut tower alignment just before it gets welded. As you can see now, all of these spot welds that were broken now line up again where they were supposed to. I've also ground off and cleaned all the areas that are going to be welded, and again, all of the cracks have the ends of them drilled with 1/8-inch holes. When doing sheet metal repairs, it's highly recommended that you use the TIG welding process instead of the MIG welding process. This allows you to control the heat very accurately and also not add any filler until you know that the metal is clean and it's ready to accept the filler rod. When welding sheet metal, typically the beginning amperage you're going to want to set on your TIG welder is going to correspond to the thickness of the sheet metal that you're welding. The metal that we're welding today is about 1 millimeter thick, or about 40 thousandths of an inch. So I'm setting the TIG welder to 50 amps, which is just past the high point on welding 40 thousandths or 40 amps to weld the sheet metal together. Let me explain why it's important to set that peak amperage on your TIG welder to just above what's needed while you're welding. Think of your TIG welding pedal as like a gas pedal in a car. Now imagine that pedal can go from 0 to 100%. Now imagine if 100% was 200 amps instead of 50 amps. Now you would only be able to use 25% of that throttle motion to weld the 50 amps that you were welding at. Now if you set it at 50 amps, then you would have 80% of the travel of that pedal to weld the 40 amps required to weld the metal that you're welding. This will give you much better control over the amperage as you're welding. Now that the bottom side is all welded up, we can get back to the top and we can make the patch pieces for the material that we removed earlier. I'm going to use the same method I did when I made our engine mounting brackets for the transmission mount. I'm just going to use some construction paper, and for most of these templates I can just press the paper along the area that needs to be patched, and then I can cut it out and then keep trimming the piece of paper until it fits perfectly. Once you're happy with the fitment of your paper template, then you can transfer it onto sheet metal. Luckily, working with sheet metal is very simple, and you can use things like tin snips for cutting out these patches, which is exactly what I did. After I trimmed it out, then I just sort of hammered it over the edge of my welding table to create a nice radius that matched the top of the strut tower. I then drilled a hole in the center of the top of it so that when I was done welding around the outside, I could rosette the center of it back down to the original strut tower. When butt welding sheet metal together, it's very important that you get the fitment as good as possible. Take your time as you're installing the patch piece to tack weld in one spot and then check the fitment in other spots before you tack weld more of it. You can hammer if needed, you can press if needed, but make sure that as you're tack welding around, all of the sheet metal areas are aligned correctly. This will make sure that your weld is consistent, and if you need to grind the weld off to make the top of the sheet metal flat, you can do that easily without leaving a step along the side. After you have the patch piece tack welded in place, before you weld it, you should go back and clean all of the surfaces that you're going to weld. I like to use a little wire brush and then blow it off and make sure that all of the dust and debris is away from the area that you're welding. Once you're happy with the fitment of the patch piece, then you can go back in and finally burn it all in. Take your time welding between 1/4 inch and 1/2 inch at a time. Welding sheet metal is a little bit tricky because it gets hot very quickly as you're welding, and you don't want to overheat the metal because it will warp for sure. Because the thin metal tends to heat soak while you're welding, it's good practice to move around instead of welding in straight long lines. Weld a little bit here, then move over to another spot, weld a little bit there, and then go back again. This will ensure that the metal stays as flat as possible. Because TIG welding is much more precise than MIG welding, grinding off the top of the weld to make sure that the top of the strut tower is flat is very simple. I just use a 3M grinding pad, and then I go back with a little rotary file and I'm deburring the square edge along the inside edge of that strut tower. This is going to blend the edge of the metal so that you can't see where the weld started and stopped. Lastly, I'll go in and just deburr the top side of it. Sometimes for good measure, I'll take a jitterbug to the top surface. This makes the top finish uniform and sometimes can identify any low spots in the metal that you missed while you were grinding. With the patch on the front of the strut tower done, now it's time to move to the back. This one is obviously a little bit more difficult to make. I did, however, use the original piece that I cut out to begin my template for the new sheet metal patch. I traced around the outside, plus when I cut it out I made it a little bit larger so that I could just sand it into size. I hammered the edges of the part over the edge of my welding table very carefully, and I also used a punch in some places to form the metal to the shape that I needed. The rough shape is pretty close here, but I'm going to go back in and I'm going to drill the hole for the upper control arm mount, and then I'm going to do the final fitting. With the hole made for the bolt sleeve that holds the upper control arm, I did the final shaping of the upper piece to get it to fit just how I wanted. Now, while it's not 100% perfect, it is still 100% better than it was before, and that's all that we're really going for here. Because of all the hammering that was done to the strut tower to get it seated back into place again, it's still going to require some filler on the top of the tower to make it look correctly. So any deformity of this filler piece that I've made can be corrected with a thin layer of body filler before we go to paint. Welding in the back patch plate is the same process as welding in the front plate. It is a little bit longer though, so I'm going to spend a little bit more time hammer forming into place so that the edges of all of the sheet metal line up correctly. This is again going to make sure that when I butt weld it all together and I go to grind the top of the weld off, there aren't any steps along the weld. Because this patch piece is a little bit larger, it's especially important to move around while you're welding, like I said on the front of the strut tower. Weld maybe 1/2 inch to 3/4 inch at a time, move to an opposite location on the patch piece, weld some over there, and then go back again. This will keep everything aligned correctly and prevent the warping. The deburring process for this weld is the same as the one on the front of the strut tower. I just use a 3M pad to buff off the top, and then I'll go back in and maybe I'll jitterbug and just sand a little bit more until the top surface is smooth. The end result is a strut tower that's better off than it was before we got to it. While the repair is not as good as an original strut tower that had never been damaged, it definitely has a much better chance of surviving now that we've repaired it. Here's a before and after again for you to take a look. With the strut tower repair done, now we can move on to doing some body work to the upper radiator support and the headlight surrounds. Both of these headlight surrounds were welded onto the radiator support as part of the INX conversion. The passenger side one, however, was in pretty bad shape and it was not really repaired when they installed it. So I'm going to go in, and I've already done most of the sheet metal work to straighten it out, but I need to go in with some body filler and I need to fill all of the low spots of the sheet metal and cover up all of the welding that was done to install them onto the core support. For all you body guys out there, please bear with me. I am definitely not a body guy, but the process of adding filler to the tops of sheet metal is not that complicated. You do small batches at a time and you do thin layers. The filler tends to shrink as it dries, so if you put too thick of layers at a time, it'll tend to crack as it's drying. So make sure that each layer is put on as thin as possible, just enough to fill the low spots. Adding filler that doesn't need a ton of body work is a pretty simple process. Usually it only takes me about 2 applications. So the first application is just going to be getting all the low spots taken care of. I'm going to let that dry and then I'm going to sand it smooth. Then it's going to expose just the last little areas that I missed or the little areas that shrank up or cracked or needed to be addressed, and then I'll do one final layer. The sanding process is pretty straightforward. I use a sanding block on any flat surfaces and just use a hand sand on any of the areas that are contoured. Here's how we're looking after the first application and some sanding. Everything looks pretty good. I'm just going to do one final application. I also need to add filler around this square area right here where the headlight adjustment is. I decided not to put filler in there the first time because I knew that I was going to be doing a lot of detail work on it, and I wanted to spend all of the time on that on a second application. The top of the strut tower is all completed here. Everything is sanded smooth. I've used the minimum amount of filler as possible as to reduce the filler from cracking after we install the nut again that holds the upper control arm. I think this will end up looking pretty good when it's completed and painted. Moving over to the driver's side headlight, you can see that there wasn't much filler required at all. There was a couple of low spots, and then I just added filler to the backside where all of the welding was done to hold it to the radiator support. I also reapplied the filler where the headlight surround meets the fender well because the bodywork that was done here before was cracking, and so I had to reapply it. So all we've got left now for filler is just the cracked area on the front of the strut tower and the square area on the headlight surround on the passenger headlight. Then we'll be ready to start prepping for paint. Here's how we're looking after all the bodywork is completed. Next, I'm going to go around the engine bay and look for any potential problems that we might run into when prepping and painting. Now, the front of this car had a pretty major power steering leak before that sprayed power steering fluid and gunk and a bunch of gross stuff underneath the driver's side headlight. So I'm definitely going to have to go in there and clean all of that out before we can prime and paint. Now, the best way to get all of the gunk out from underneath this headlight would probably be a pressure washer, but I don't really have that option with the car sitting inside of our shop on the lift. So instead, I'm just going to use a little bit of carb cleaner and let it all drip down into a little drain pan. Once I've removed all the gunk and grease out of the engine bay, the next thing I'm going to do is start scuffing up the painted surfaces. I like to use just a normal household green Scotch-Brite pad to go around the engine bay. It really does a good job of scuffing surfaces for primer. Some things that are often overlooked when painting an engine bay is finding all of the chassis plugs that are around the engine bay. I like to pop them all out and save them so that they can be reinstalled later. Another thing to look out for is hardware that's protruding into the engine bay from outside the engine bay or inside the fender wells, like this guy here. Those are the things that are going to make all the difference on the quality of the paint when you're done. Lastly, anything that's not going to be completely removed before you paint the engine bay needs to be masked off. While there's many different ways to do this, I like the typical masking tape, and then I just shove some rags around the edges of all of the seals and holes so that any additional paint that might try to sneak in to behind the firewall is actually absorbed with the rags themselves. So painting an engine bay can be tricky when you don't have a paint booth. Now, this is the second time that I've painted an engine bay on my lift, so I kind of have an idea of what worked the first time and what didn't work. Let me show you how I'm going to get this done. Welcome to JSP Collision and Auto Body. The last engine bay that I painted in here was my AA86, and I used some supplies that I got from Finish Master in Corona. They supplied me with all of this same materials. Now, they no longer do aerosols, so I had to pick this up from a different vendor. But here's what you're going to need. This sweet jumpsuit was about $15. The box of masks was about $20. You're going to want about 4 cans of colored paint, 3 cans of clear, and 2 large cans of primer. That's the combination that I found works best. The total cost for all of these automotive supplies was about $380. Now, while for aerosols that sounds like a lot, the quality of the paint is much better than what you can get out of a normal aerosol can or a spray paint. The last thing to do before spraying is masking off everything that could potentially get paint on it. Now, this is a process that can seem tedious, but you're going to be very thankful that you did it when you're done so that you don't have to worry about cleaning paint off of surfaces. All of these plastic tarps and paper is available through places like Home Depot, and it doesn't cost very much to purchase. I recommend that you do the best that you can to mask off as much as you can. In this case, the whole car is wrapped, and additionally, I've put a little fan underneath the car to create a little bit of a downdraft. One thing that I've learned over the years spray painting is that warming a surface before you paint it makes a huge difference in the adherence of the primer and the paint that you apply. Now, there's different ways to warm surfaces, but the easiest for me is just to use a little bit of a torch. I just sort of loosely go over all of the surfaces with the torch warming it up a little bit. Another thing that the torch does is it exposes any surfaces that may have any oils on them, and it'll cause it to smoke or to boil. That way you can go back and clean those surfaces again more thoroughly before you begin painting. When painting something that has multiple angles and areas to reach, I've found that it's easiest to start in the areas that are the hardest to get to. So underneath the headlights and around the edges of all of the things that are going to be painted is the best place to start. This way you can move around the car easily without worrying about bumping into an area that you've just painted. The most important part about applying a paint like this is making sure that your movements are all smooth and even. You keep the can a consistent distance away from the surface that you're painting, and in this case I like to keep the can about 8 to 10 inches away from the surface that's being painted. Now, in my opinion, the primer layer is actually the most important layer of paint. So take your time to get into all the tiny little crevices and tight areas. Make sure that every part of the engine bay is covered in primer. This is going to ensure that the base coat goes on smoothly and adheres permanently. One thing that is often overlooked when painting something like this is your approach angle for the paint. It's important to paint from different sides of the car, including outside of the engine bay towards the inside of the engine bay. This will make sure that everything lays evenly and there aren't any dark spots or uneven spots when you lay the base coat. Here's how we're looking now after the primer is laid down. Everything went on smoothly, there wasn't any adhesion problems at all. Now this primer needs to dry for about 30 to 40 minutes before the base coat can go on. If you noticed any blemishes or flaws that needed to be sanded, that needs to be done after the primer dries, and then you need to apply a second coat of primer before putting the base. Applying the base color is the same as applying the primer. I try to do all the nooks and crannies first before doing all of the large exposed areas. Now be careful. The base coat is much thinner than the primer coat is, so it's very easy to apply too much paint and get runs. Work your way slowly around the engine bay, laying nice clean layers of paint. When I do the base coat, I do 2 to 3 layers of the same area. This way I can ensure that the base coat is sticking to the primer, and then each additional coat on top again just adds more vibrance to the color. When it comes to painting, slow and steady is always the best way to go. Anytime you rush something like this, you're going to regret it, and you're going to undo all of the work that you've put in up to this point. As mentioned earlier, it's important to attack the engine bay from all different angles. This is going to reduce the chances of having any dark spots or any areas that have thinner amounts of paint than others. In the end, it's going to result in a much brighter engine bay and a much more professional looking job. Here's how we're looking after the base coat went on. Again, everything went really smooth. I think a lot of it has to do with how the primer was applied and how the base coat was applied slowly. This base coat has to dry for another 30 or 40 minutes, a lot like the primer, before the clear goes on. And then the clear goes on in the same way as the base coat. But again, be very careful because the clear is in fact clear, and you can't see how much is going on. The best way to apply the clear coat to prevent any running is to apply it as lightly as possible on the first coat. This is going to ensure that you have a clear coat on the entire engine bay. Then you can go back and start applying more clear to the areas that you want to have the most amount of gloss. Please, once again, take your time when you're doing this. The application process for each layer for me is probably about 10 minutes. Each can is slowly applied until I'm sure that everything is adhering properly. If you take your time and do all of these steps correctly, the result is going to be an engine bay that has almost a professional look, and it can be done at home. For anyone doing an engine swap like this in their older chassis, I highly recommend taking the extra time to repaint the engine bay. It makes a huge difference in the way the engine bay looks when you're completed after your engine swap is done. Not to mention, assembling an engine bay that's clean with fresh paint is much nicer than assembling an engine bay that's covered in grease and grime. Do yourself a favor and make your engine bay a little bit nicer before you put that engine back in. Let the paint dry overnight. The next morning you can come back and remove all of the masking tape. You're going to be surprised at the result. As always, thanks for watching, and if you have any questions or comments about our Prelude build, please leave them below.